In this example, you're to calculate the area in square units bounded by f of x equals to 10x cubed plus 8x squared minus 17x minus 4, and g of x equals to 9x cubed plus 10x squared minus 2x minus 4 over the interval from 3 to 7. So the first thing you would want to do is to find out if there's any points of intersection of the two functions within this interval. So the way you would do that is you would set the two functions equal to each other. So we have the 10x cubed plus 8x squared minus 17x minus 4 equals the 9x cubed plus 10x squared minus 2x minus 4. Now to solve this equation, what I'll do is get everything with x on, or everything on one side, 0 on the other side. So let's subtract 9x cubed from both sides, we'll get x cubed. Subtract 10x squared from both sides, you'll get minus 2x squared. And then add 2x to both sides, you'll get minus 15x. That's the add 4 to both sides, that cancels out, so you have that's equal to 0. So what I would do next with this polynomial equation is see if I could factor the left-hand side. I could factor out an x. So I'd have x times x squared minus 2x minus 15 equals to 0. And that could be factored further to x times x minus 5 times x plus 3 equals to 0. So that gives us the x coordinates of the points of intersection would be what, -3, 0, and 5. Okay. Now, within the interval from 3 to 7, the only one of those points of intersection is 5. So what that tells me is we're going to break up this interval into two intervals. We're going to go from 3 to 5, and then from 5 to 7. Now, we could have it with both, because when it's at one specific value, the area that's actually equal to 0. But anyway, now the next thing you would do is you want to know which function is on top of the other function within these intervals. So like I'll plug in maybe 4 into both of the functions, see which one's larger, plug in 6 into both of the functions, see which one's larger. This is just calculator work. So plugging in f of 4, what you would get when you plug in 4 into the function would be 696. G of 4, what you would get is 724. So that tells us that the g function is on top of the f function within the first interval. And then just to verify that it switches, well, let's see, f of 6, that would equal to 2,342. G of 6, that would be equal to 2,288. So yeah, it did switch. So when we do the first interval, like I was saying, the g function would be on top of the other one. So we'll do the interval from 3 to 5 of g of x minus f of x dx. And then for the second one, we'll do the integral from 5 to 7 of, then it'll be f of x minus g of x dx. Okay, so for this first one, let me do one piece at a time. So when we go from the integral from 3 to 5, so we'd have, like we're saying, g of x minus f of x. So if we subtract those, so it'd be the 9x cubed minus 10x cubed, and then the 10x squared minus 8x squared, the negative 2x plus 17x, and the negative 4 plus 4. What you would end up getting would be negative x cubed plus 2x squared plus 15x dx. Kind of looks familiar, right? Because it's just like this, except it was on the other side. Okay, so that would be, integrate that, be negative 1/4 x to the 4th plus 2/3 x cubed plus 15/2 x squared. Evaluate that from 3 to 5. So this is just now calculator work. So plugging in the 5, so you'd have negative 1/4 times 5 to the 4th plus 2/3 times 5 cubed plus 15/2 times 5 squared. All of that minus plugging in our lower limit, so that'd be negative 1/4 times 3 to the 4th plus 2/3 times 3 cubed plus 15/2 times 3 squared. And, well, just doing some of the steps, like not every single one. So this will be what, negative 625 over 4 plus 250 over 3 plus 375 over 2. That minus the negative 81 over 4 plus 54 over 3 plus 135 over 2. Don't forget to distribute that minus sign. And then you'll get common denominators and everything. What you'll end up getting, just again to save time, this will be 148 over 3. Now for the second integral, that'll be the integral from 5 to 7. And now it'll be the f of x minus g of x, so it'll be of the x cubed minus 2x squared minus 15x dx. So it's just about the same, except it's now positive 1/4 x to the 4th minus 2/3 x cubed minus 15/2 x squared. Evaluate that from 5 to 7, and so that would be plugging in your 7. So it'll be 1/4 times 7 to the 4th minus 2/3 times 7 cubed minus 15/2 times 7 squared. All of that minus plugging in your 5, so that'll be 1/4 times 5 to the 4th minus 2/3 times 5 cubed minus 15/2 times 5 squared. Now just to save time, so that would all equal to 356 over 3. So the area would be the sum of those two, which is, so you'd have the 148 over 3 plus 356 over 3, which would be 504 over 3, which would be 168 square units.